Hey, welcome back. So last time we wrote a little script which will help us with our training. It can build a neural network. It will save the stuff in some sort of versioning so we can remember what we did in the past. And before I start now, I think I will just commit everything. So we had some changes to our neural network bot. Oh, what's happening here? This was good. Some logging changed somewhere. This is good. So this is the part of the tutorial. I haven't quite written this part yet. One add, 9 adds white space errors. Yeah, whatever. This is we can fix this later. We're gonna commit this as ep1 setup of training. Okay. In this video, I want to start actually running this in a loop. So we need to still work a little bit before we can generate enough training data. So, we ran it manually once. But I want to run this in a loop now and then slowly set up the reinforcement learning specific training instances. So the easiest thing we could do is for range epochs. Let's make an epochs or games. Let's call it games. Non-games. Let's do games. Initially, we're not going to change the seed. So first, we will see, can we use the neural network to learn something similar that we learned with our Q table, which would be, in the first 10 moves, can we find the best possible path? Well, and then after that, we actually gonna increase the number of moves and see, can we learn something in the first 100 moves, which is better than the first 10 or something. And after that, we will also randomize the seeds of the maps. So can we generalize over different maps? And after that, we will add more ships to the mix. So first we say for episode in range number of games, we just call this. Okay, this would be working. We should probably print something. So tqdm, and then we have tqdm. This will make the output look a bit nice, and we put this up here. And then let's see if it's not a terminal anymore. Let's just run it for a couple of episodes. I hope I set the starting epsilon. This is not what we want. We want a starting epsilon of 1.0. Can we actually have these constants closer to our code down here? Difficult. So now it works. Okay. Ah, yeah. Okay, there's already something which is not working. File does not exist, so we did not create this directory. And I thought we implemented here training data path because it has a double slash maybe. File exists error. Then it's now both bots competing for this folder. It's nothing we need to fix right now, actually. I will keep it in mind. We will actually turn down verbosity of the logging a little bit. Verbosity? I don't know. Let's see if this works. Only one file, which is weird. So it's not writing the files as it should. Maybe it was, there they go. Oof, this took a while. So here we can see apparently the ships crashed. This one is probably also the ships crashing, but actually ships crashing, but collecting a little bit of resource. So this was probably the same game. One is the one bot, one is the other bot, and this one is actually quite good. It's collecting something. Okay, cool. One other thing we do not need to do. No replay, I think. Hang on. Does it say no time, no replay? And then we need this and this. Okay. You see that running these games actually takes quite a bit of time. Like there's some overhead on loading TensorFlow every time, which strictly speaking is something we do not need to do, since we do not use a model right now. It takes about 3 seconds for one game, and it's only a 10 turns game. Okay, we can already, we let this run a little bit just to collect some training data, then we will build some more stuff around here. So we actually run num games, and then here we want to take epsilon, we want to start defining an epsilon. Starting epsilon, and then here we want to say this epsilon, not discount, epsilon decrease maybe, and then we're not gonna wait until 1,000 games finishes. This takes way too long. Maybe you hear my PC fanning up now. This is taking quite some time. I think maybe we can speed this up somehow later on. For now, let's leave it like this. Synchronize this and see. Okay, a couple of stuffs comes in. Okay, so we always multiply epsilon with 0.95. This will now, across different episodes or epochs, I don't know how you want to call it, this will increase the amount of decisions we make by our model. So, but in order for this to work, we actually need to update this command. So, and then instead of starting epsilon, we want to pass epsilon. So, and then while, I don't know, true for now. Technically, this could be a loop. So, we build our command with the current epsilon, we run some games, then we would do train network, update epsilon, and run more games. Is this how we want to do it? Let me get the num games parameter down. In each epoch, I think, since we have 20 samples per game, let's make it 20, I don't know, something like this. And then, okay, we do this OS system command. We can also do this in parallel depending on how many cores we have. And then let's actually stop this one. Continue. Okay. Okay, what we need to do here now is we actually need to know the training data path, which would be globe for file in globe and then training data path plus, I guess. We want all the npc files, print file. Let's set numGamps to 0 and see if this works. And here we actually just break and finish. Okay, this should now doesn't find anything. Print training data path is set to training, already has a slash. Maybe this is not good. Oh, yeah, let's make this an f string. Oops. It has a slash epsilon. Zack. This is the current. Okay, here we see it takes our files. Okay, one thing we can do here is we can say reward gleich split. We split on the slashers. We take the leftmost entry, then we split this one on the this is not good. Let's make it on the underscores because oh shit. Yeah, I will change this to underscores. It's a bit of a waste that we ran all of this, but split underscores, take the 0th element, and this will be passed as an integer. This would then be our reward. Total reward equals num and total reward plus equals this one. And there's better ways on doing this. Okay, so for now, let's delete both of them. And then let's say we run 5 games. And then actually here we want to print total reward. Let's do an f string episode. Let's call these things epochs because we're gonna train in between. And then epoch, I'm gonna define this. Total reward equals and average reward and this should be rounded to some precision, maybe 2 is fine, whatever. And in range epochs. Let's run for 10 epochs. I don't know, because import globe can be go to the top. And then nodes. Here we would actually load. Okay, yeah. Okay. Of course, this I forgot. I actually forgot to change this. This was unnecessary. Delete. In here, we want to change the naming to be underscore here to not confuse it with the minus. Of course, we could have various ifs here, like if there is 2 dashes in the file name. This is annoying. We have to fix this. Is there any way of silently creating this, I don't know. We have to go here and see, does it take any real signature unknown? Yeah, whatever. We should check the documentation of this to find out. And then here we can see our total reward is minus 1800 and our average is minus 258. The more games we play, the more accurate this would get. And then we hope that across the different epochs, we would see an increase in average reward. Okay, now that we have this, we can load the data. States append numpy. Did I already import numpy? No. Numpy load, then file, and then in these numpy arrays, unless you specify a name or something, it is always stored in array 0. So this would now be training data, I don't know. So now we just load all the files all the time. Okay, cool. This should actually work. Then what we want to do next is, how do we train our model? There is various ways on how you can do it. So I think what happens in the DeepMind paper about beating the Atari games, they actually train the model every couple of steps that they take. So I don't know, they take 20, 100 steps in whatever episode they are. Then they train the model, and they take the next 100, then they train the model. Since I don't want to implement the model training in between games, I will always run full games, then I will train on those. And there's something that they call experience replay, where you basically keep a list of all training data that you have seen in the past, and then you randomly sample from that when you train your model. This should help to not forget stuff that you saw far in the past. Like, I don't know, if you play Super Mario or something and you first train on level 1, then you're really good on level 1 and you finish it, then you play level 2, but you only train on level 2, it forgets how to beat level 1. So they shuffle all of these data points. For now, since we only have one seed, it doesn't matter. There's only one map anyway, but later we're gonna do this. I'm now gonna implement the simplest version. We just train on all the training data that we have now. We update our epsilon, we play more games, we train again. So and then now we have state. Oh, what do we write in here? We write the state, action index, reward, done. No, what do we write? States, action indices, rewards, and done. So here we want to do a similar loop like in our Qtable bot. State, let me first do this in training data, and here we actually want to zip training data with training data, and then starting from the first element, because we want to have the state, action index, reward, done, and we want to have next state, action index, reward, done. I think we can unpack it like this. Looks a bit ugly, but yeah. So our current queue would be model predict state, and our future queue model predict next state. If done, new current something like this, and else we have a similar formula to before. Let me just see how do I if done target is a reward. Here let's see, states targets. Yo. Yeah, let's define this as new Q value equals reward. We can do this, and if not done, then new Q value equals this. It's immediately discount, future discount, reward plus future discount times MP max future Q. So this is, I think, the same as we used for Q table. Now we just use the Q values from our network, and then we train states I don't need because they don't change. Yeah, well, states train rewards, train y, let's call it x and y, I don't know. Something like this, append, and new append is current Q, and we update current Q action index equals new Q value. So what does this do? Our current Q will be an array with 5 choices, 5 different moves. Whatever the model predicts might be the best move. And the model tries to predict the actual reward that we would get in this state. And we say if this was a terminal state, then we know that the reward is whatever's reward given. If it's not a terminal state, we take the reward that we got right now plus a future discount of the maximum reward that we expect to get in the future. And then we take this array with 5 values, and we say for the choice that we actually made in the game, we want to now have the new Q value. Now if we do back propagation on this, this will basically say our network predicted everything right except for this single value. So the error that's propagated back will only be according to the current action. And I think in the paper actually they had their network in a way that they have a mask which they pass through. So they have 2 input layers. One input is actually the state of the game, and the other input is the action that was chosen, and they mask in the output with either zeros or ones, what can be back propagated or what not. But I think this is the same effect. We only want to have back propagate one error. So and I think what we can do now, we can basically just say model.fit train x, train y. Let me just check up on the states, targets. Then we have these parameters which I want to copy. Epochs, blah blah. So then we fit our model. Now it's not saved, so our model would not be used in the next iteration. So I want to do model save. Is this the correct model save model path. Okay, so this would override the current model path, and then I actually also model. I actually would also like to, let me just see what's model path. Model path is just model, and then we have this weird folder. Na gut, I actually experiment path want to save something in experiment path slash epochs slash model, I guess. So this would be the model for this epoch. So we overwrite the current model, we save the model for the current epoch. Maybe we should do this before that we also. So this would save for epoch 0, would be the original model. Epoch 1 would be the model after the first epoch. Is this weird? Yeah, we don't save the random model. Anyway, let's see. This is probably going to crash on us a couple of times. So you see that these epochs and these epochs are actually different things. So this is just how often do I train the model on the current data set. And this epoch is actually how often we decreased epsilon and how many games we ran there. So we can try this and see if this crashes on us. This is also why I should probably create this folder in training script instead of inside the bots. So we're going to run this. If it crashes, we fix this in the next episode, I think. But technically, I think, arrays cannot be loaded. What's happening here? We should probably have some debug stuff. Print file, and then instead of running 5 games, we run only 1 because we have some stuff already. Zack. Aha. Oops. What's happening here? Dot load. Oh, come on. Keys. Let's just see. Array 0. np load file. Allow pickle fails. False. I've never seen this before, but I'm not gonna do this. I don't know. I'm gonna check why this seems to be writing in a way that is not good. And then we're gonna fix this in the next episode. Probably I'm gonna fix this offline and just show the result in the next episode because it's not that interesting. Okay, see you.